So a second quick one, and then we're done for part one. Let's say students at a school are downloading an exciting new app. The probability of a randomly selected student having the app next week is 0.3. So let's determine the likelihood that out of a class of 25 students, 2 or more will have the app. Well, if 2 or more will have the app out of the 25, you can imagine just how involved coming up with the list of all the different combinations similar to what we saw in the first example. So I don't think we want to go there. But we are saying, for example, in terms of success and failure, the probability that students download the app is 0.3. That's your success. And then 1 minus that is that they don't have the app. That's your failure. Showing this kind of notation to an IB examiner would be quite useful to show that you're on the right track with the binomial. We need the probability that x, that random variable, is actually 2 or more, so greater than or equal to 2, where that random variable x is the number of students having the app. Again, that's a lot of work, which we would never want to do, but classically we'll consider that the likelihood that the student selected 2 or more have that app, then 1 minus the probability that it's 1 or fewer, if you will, which looks like 1 minus the addition of those two. Again, this kind of notation is not necessary to write it down, but could get you a method mark if you do so. So what I've done would be 2 things for you here. So the likelihood of 2 or more having the app, which is 1 minus 1 or none having the app. Well, here it is here. 1 minus, here's no students at all out of the 25 having the app, because here's the likelihood of failure. And then combining 1 out of the 25 will give you actually 25 times this arrangement here. So you see a value here. Again, this kind of methodology, not needed per se, because we're talking about a CDF feature. Number of trials is clearly n equals 25. Likelihood of success is the 0.3. You're putting in the x value of 1, y, in the CDF sense. Up to and inclusive of 1 really just means 0 and 1 already being done for you. So when you bring that binomial CDF, paste it back to the home screen, again the CDF function, you get this very small value here, and 1 minus that, which is the complement that we need to actually answer the question, is exactly the same value that you see here. That's it for part 1. Look for part 2, and I hope that was clear. Bye.